Hello, welcome to my channel. In today's video, we will be discussing about ergonomics approach in automotive design. Ergonomics associates with the science of designing for human use, comfort, and efficiency. In automotive design, ergonomics ensures that vehicles are comfortable and safe to operate. This video, we will cover four main principles of ergonomics approaches: fitting equipment to the user, designing for the population, the systems approach, and problem solving methodologies. Together, these concepts guide automotive engineers to create car interiors that prioritize the needs of drivers and passengers. Let's start with the first one, which is the most fundamental principle of ergonomic approach, that is, fitting the equipment to the user. This approach means that the equipment should naturally fit a person's body and abilities, reducing the need for them to stretch, strain, and adapt uncomfortable postures. In vehicles, this principle is applied in designing adjustable seats, steering wheels, and mirrors that adapt to the various body sizes and proportions. This adaptability allows a wide range of users to comfortably operate the vehicle while maintaining full control. The idea is the equipment should not be designed first and then user should adjust. While designing the equipment or the product, you need to consider users, postures, and dimensions. Another example, consider how adjustable seats and steering wheel positions allow both taller and shorter drivers to reach pedals and see the road clearly without straining. By accommodating these diverse physical requirements, we not only enhance comfort but also ensures driver safety. The second crucial principle of ergonomics is design for the population rather than the average user. That is, designing for the most. In this context, it's important to consider the diversity within the population. Factors like height, arm reach, leg length differ widely among the individuals. Designing only for the average person often means that large portion of the users won't be comfortable or fully accommodated. Instead, automotive engineers aim to design for the broadest possible range of people. This is why seats, controls, steering columns are highly adjustable, allowing each driver to customize their step setup for the optimal comfort and control. Another example, while the average driver might sit at the specific distance from the pedal, taller individuals need to push that seat back and shorter individuals need to bring that seat forward. Vehicles that allow this range of adjustment are much more inclusive and functional, minimizing the chance of discomfort or fatigue during the longer drives. The third approach is the systems approach, is another vital component of an ergonomics approach in automotive design. This principle emphasizes that humans should be considered as an integral part of entire system. Rather than seeing the driver as a separate for a vehicle, the system approach considers them together, that is driver, a vehicle, and including the environment in which we are driving that vehicle. This perspective requires engineers to consider both internal and external factors impacting the driver's experience. For instance, from designing dashboards and instrument clusters, designers consider lighting conditions like daytime light, glares, or nighttime visibility to ensure that critical information is always accessible for the driver. As the diagram suggests, it basically covers characteristics and capabilities and limitations of the user, plus the vehicle's size, type, body style, space, systems, and other subsystems and components included, and then the environment like road, traffic, weather, the light condition, day or night or dusk, whatever it is. Again, the example for this can be dashboard displays are often angled or backlit to improve visibility in different lighting conditions, ensuring that important data like speed or fuel level is clear without causing distraction. Finally, let's look at the problem-solving methodologies in ergonomics. These methodologies are basically guess, modeling, and experimental testing helps designers to develop, test, and refine ideas to ensure ergonomic efficiency. Let us look at one by one. A guessing is often used in the initial design phase when engineers ideate how a certain design might meet human needs based on prior experience. Although it's an educated guess, it's typically followed by more rigorous methods. A modeling involves using digital simulations and physical prototypes to predict how designs will function. For example, engineer might use a digital model of a car interior to visualize how driver of various sizes would fit, allowing for the adjustment before creating the physical prototype. An experimental testing is a hands-on method where real users interact with the design. This feedback is essential for prioritizing design elements that may need adjustments. For instance, testers might use a prototype car seat and their feedback help engineers to improve aspects like lumbar support or seat angle before the seat goes into production. These principles of ergonomics are applied across all aspects of automotive design, from the layout of driver seats or steering wheel to the positioning of controls and displays. For examples, many car models now include adjustable seat heights, lumbar bar supports, armrests, enabling drivers to customize their sitting positions for better comfort and reduce fatigue for long drives. Such features are not only functional but also contribute to the positive and enjoyable driving experience. In conclusion, the ergonomics approach in automotive design emphasizes fitting vehicles to the people, accounting for diversity, considering the system as a whole, and using proven problem solving methods. That's all about this video. Thank you for watching. If you like this content, do subscribe my channel. Thank you for joining.